How's it going, ladies and gentlemen? Today we're going to be talking about quadrilaterals and more specifically a parallelogram. So just to be clear, a quadrilateral is a four-sided shape. So quadrilateral is a four-sided shape. One of the more specific types of quadrilateral is a parallelogram. By definition, a quadrilateral that has two pairs of parallel sides is considered a parallelogram. So, in this quadrilateral, what I want you to notice, it's a parallelogram because AB and DC are parallel to each other, and AD and BC are also parallel to each other. So as a reminder, these little arrows mean, matching arrows like this, means these sides are parallel and these two sides would be parallel because their arrows match. The symbol for a parallelogram is this simple slanted, looks like a rectangle. Is just a slanted rectangle here. That's how we write the symbol. And the way we name a parallelogram is basically listing all the vertices in order. So A, B, C, D. The way you would read this is parallelogram A, B, C, D. You also could list it as parallelogram D, C, B, A, as long as the letters you use are in consecutive order, one after the other. So parallelograms have some properties that we need to kind of memorize for parallelograms. So properties that tell you stuff about their different parts. So they're broken down, and they're broken down by sides, angles, and diagonals. So we're going to go through each kind of the truths about the sides of a parallelogram. So the first thing we have to understand is in a parallelogram, opposite sides are congruent. Okay, so what that means in this particular example here, we can now say that AB and DC are equal and AD and BC are equal. So if I write that down, it looks something like this. AB is congruent to DC and AD is congruent to BC. So that simply means if this side is AB, if this side has a measure of 10, then this side has a measure of 10. Okay? So next we're going to talk about the angles in a parallelogram. So the angles in a parallelogram are very similar to the sides. Opposite angles are congruent. So opposite angles are congruent. So that's one thing. So what that looks like is this idea. Angle A is opposite angle C, so therefore angle A has the same measure as angle C, and angle D has the same measure as angle B. Okay? The second thing that's a property of angles is consecutive angles, so angles next to each other, are supplementary. And supplementary is just a fancy way of saying equal to 180. So they have to add up to 180. So in our diagram, what that means is angle A and angle D, these two angles added together should equal 180. Okay? Last but not least, we're going to talk about the diagonals. Just in case you're not sure what a diagonal is, I'm going to draw one in now, and it's simply this. A diagonal is a line that connects opposite vertices together. So this blue line represents a diagonal, and we have two of them here. So I have two diagonals in this parallelogram. And what's special about the diagonals, or the property of diagonals, is that in a parallelogram, diagonals bisect each other. Okay? And what that means is these diagonals cross each other and cut each other into two equal parts. So looking at our diagram, I can now say D, and we'll call this point E, where the diagonals intersect. I can now say that D to E is equal to B to E. So this guy has the same measure as that guy. On top of that, we could also say A to E is equal or congruent to E to C. So the line AE has the same measure as EC. Okay, so diagonals bisect each other. So what that really means, it creates equal lines, as mentioned above. Okay guys, that's it. In Google Classroom, go ahead and make a comment telling me one of the properties you learned about a parallelogram.